My name's Paul Gruby. I'm a science teacher at Woodkirk High School Specialist Science College. This is my lesson about using trial and improvement to create different coloured solutions based on the work the students have done using acids and alkalis and the pH scale. It's a really colourful lesson the children find interesting. They get to mix lots of different things together and have a lot of fun whilst learning the importance of working carefully. One of the most exciting things I think you can do in chemistry is to change the colour of something and change its appearance completely. And that's one of the things you're going to be trying to practice to do today. For example, I know exactly how to take this blackcurrant squash and to pour it into a glass and turn it into lemonade. In the first demonstration, I'll use potassium permanganate solution, but I do tell the students that it's blackcurrant cordial. I'll pour it into a series of glasses, all of which have a different reagent at the bottom to start a chemical reaction and a colour change. Or I can turn it into water. Okay? I can turn it into a smoothie. Right? All from the same bottle. In the first one, there's nothing at all, so they can just see the glass of blackcurrant. In the second one, there's a little bit of sodium thiosulfate, which removes the colour from the blackcurrant juice, and it looks like a glass of water. In the next one, there's a solution of barium chloride, which with the acidified permanganate in here, will produce a blackcurrant smoothie type effect. And in the last one, there is some thiosulfate to remove the colour, and there's also some sodium hydrogen carbonate, which will make it look like it's fizzing and give the impression of turning into lemonade. I think the starter worked really well today. It nearly always does. Unless something goes wrong, they love the colour changes. They love seeing colours disappear, they love seeing colours appear out of nowhere and changing the texture of a solution, making it go from something they can see through to something quite cloudy and thick. Really interests them and it gets them asking questions about why it's happening. If I pour it into this test tube though, it changes colour again. What colour is it this time, the young man at the back there?
Is it an alkali?
It's an alkali. Now, how do you know it's an alkali?
Because it's like a purple.
Yeah. OK, it's gone pink this time. Can anyone suggest why it's gone pink? What might I have had in here that made it go pink?
Like some sort of like acid?
Yeah, exactly. I had some acid in the bottom and it made it go pink. What I want you to try and do is to make the colours of traffic lights. So you're going to try and aim to get certain colours, and if you don't get the colour you want, your job is to try and work out how to make it a little bit better, how to make it closer to that colour you want. So at this point in the lesson, I've done the starter activity. They're all interested in the different colour changes they can do. What we're going to do now is I've told them what the challenge is, what their main part of the lesson is, and what their objectives are, and I'm going to get them in little groups. They're going to find friends they can work with, and they're going to start experimenting and mixing the different colours, seeing how acids and alkalis react with indicators.
If we add more alkali, it'll turn green. Hopefully.
At this point in the lesson, the students are really enjoying themselves. They're measuring things out very accurately. OK, what you can do is change the amount of it.
I've made a green and a red, but not an orange.
I'm getting on okay, but it's very hard to make orange because you have to try loads of colours and try nearly every single colour, and it still won't go in the colour that we want it to go in.
We're just about at the end of the lesson now. Most students have found it quite easy to get a red colour with the acid. A lot of them have found it fairly straightforward to get a green colour, but all of them are struggling with the orange colour. Now, the reason for that is because you've got to get exactly the right amount of acid to get an orange colour. So it's very difficult for anyone to do without overshooting it one way or the other and either going red or green.
What I liked about the lesson was changing the different colours into the test tubes.
We're not just sitting around, we're doing like experiments and stuff.
Because we got the chance to mix different chemicals together to make either an alkali or with acids and alkalis to make a different colour.
I think this will be really useful for them because they're going to go on next to study the pH of different sweets and try and look at whether sweets are acidic or alkaline, whether different sweets have different pHs. And I think they've had a really good lesson here getting used to looking at the pH and what the different colours of indicator tell you.